See, we are going to cover here CCNA version 1.1 2000301. It means this is earlier we were having version 1.0, right? So now we have version 1.1. It means in this particular new syllabus, certain new topics has been added and certain old topics has been removed, right? That's why it says here version 1.1. So what happened in the August 2024 new topic that is related to artificial intelligence were added in this. That's why we have version 1.1, right? And even what is the code we have? 200301 code, right? So earlier in CCNA also different domains were there, like security domains, wireless domains, different enterprise. So as you know that this is a starting, so how would you will be able to decide which domain I have to select, right? So that's why what they did, they have merged all the different topics coming under the same CCNA, whether it is wireless, whether it is certain security topics, or whether it is enterprise routing and the switching topics. That's why. So as you know that this CCNA is going to contain one examination also. That is not mandatory, but examination is there that is going to be of 120 minutes. It means that this is a 2-hour examinations. Let's say once we have done the CCNA course. So after doing this, you have the CCNA knowledge. Plus, you will be getting one completion certification from the institute from where you have done. But that is not certification, right? Certification means what? Once you have done the course, after that you have written the exam, and based on the performance in the exam, then only you will get the certification, right? So what happens? Let's say after doing this, you wanted to write the exam. So it is going to have 120-minute exam. Duration is 2 hours. Plus the cost of the examination is going to be $300, right? $300 plus taxes. That is, we can say GST. After that, the duration of the examination we have seen 2 hours, and validity. Well, let's say you have cleared the exam. Once you have cleared the exam, so validity is going to be 3 years. Means what will happen after that? After 3 years, your certification will be expired. After that, either you have to rewrite the exam to get recertified, or you have to take a course from Cisco, right? Second, and one more thing. One time we have paid $300. This is one time only. If let's say you have not passed the exam, again you have to pay that to rewrite the examination. Okay. How much percent you will score so that you will be passed? 82.5% is. Approximately we can say around 85% is. If you are scoring 85%, then only you will be considered as a passed. This is the pass criteria for this certification, right? This is for the CCNA. Next, same as we have CCNP also, CCI also. And there is no requirement that already in this you have to write CCNA, then only you can write CCNP. No, this is not requirement. Directly you can write CCNP or directly you can write CCI security, right? So further, when you will move forward, you will get all the idea what to write, what not to write. This is a general idea for the CCNA. Clear? Now see, here we have certain different topics that is starting from the network fundamentals. So like side-wise, it is written here the percentage also. Like what is the weightage percentage is examination that it is written. So it is having a 20% weightage. So first here we have is network fundamentals. So the names only suggest network fundamental was all the basic understanding of the networking, right? So it says that he will be explaining or will be understanding here the role and functions of the network components, like what is routers, what is layer 2 and layer 3 switches, what is this next generation firewall and IPS, access point, controllers, endpoints, servers, and power over Ethernet, right? So just basic understanding, what is this router? A router, we call it as a layer 3 device, right? Why layer 3 device? Because it operates on the layer 3 of the OSI model. When we will start the OSI model, we will have the brief understanding of this, and we will have brief understanding of each layer. So layer 3 device, we call it as a router. A router is a device that used to enable the communications between the devices located in different local area network. It means that whenever your devices are located in different network, what we use? A router we use. And what we call it is a layer 3 devices. Once we discuss with all this syllabus, again we'll start with the network devices. There again, we'll discuss in detail about the routers, its functions, and what all the specifications we have with the routers, switches, and everything. Right here, just we are having the introduction regarding the syllabus. So router, we call it as a what? Layer 3 device because it enables the communications between the devices located in different network, right? Next, we have layer 2 and layer 3 switches. See, here it is telling you that layer 2 and layer 3 switches means what? Switches are generally layer 2 devices, but nowadays we have multi-layer switches also. We have layer 3 switches also that has the capability of acting as a router, right? And one more thing, whenever we use switches, so switches is a device that is used to connect multiple devices where in the local area network, in the LAN environment, right? When you connect multiple devices in a LAN, for example, let's say you have 50 PCs, you have to connect that 50 PCs with one centralized device. How will you connect? Using a switch. So all these 50 PC belong to one same network, one same organization. Then we call it as a single LAN. Let's say one more certain location we have, there we have 10 PCs or 20 PCs. There you have connected 20 PCs with that particular switch. Now that 20 PCs and this 50 PCs have to communicate with themselves, but they both are in different locations. How they will communicate? With the help of router. That is called as a layer 3 device. And these are these switches are called as what? Layer 2 devices. But even we have here layer 3 switches also that can act as a routers, right? Next, it is written here next generation firewalls. See, here we can say that we are going to have different types of firewalls. One is called as a traditional firewall, right? And one is what? Next generation firewall. So see what is the differences between them. Traditional firewalls filters the traffic based on the source port number, destination port number, then source IP address, destination IP address. Whereas, or we can say here that traditional firewalls can filter the traffic till layer 4 or transport layer. Whereas next generation firewalls can filter the traffic till layer 7. Means here, apart from filtering the traffic based on the source IP, destination IP, source port, and destination port, even you can add multiple more features. Like I want to filter the traffic based on this particular application. Means this particular application will not be allowed. Let's say you're working in an organization. What they want that my employee should not be able to visit any particular social media websites or social media applications. Let's say Instagram or Facebook is denied for you. So when that particular application is denied for you, it means what is being done? Next generation firewall is being used to filter the traffic. Even under that particular, let's say Facebook is allowed, but you're not able to access Facebook messages. That is also possible. How? With the help of this next generation firewalls. It means here what is doing? More control of the traffic will be there compared to what in the traditional firewalls. So nowadays, whatever the firewall we are studying or we are having, that is an example of next generation firewalls, right? Then what we have? Access point. See, access point is a device that is used to have the connectivity between the wired and the wireless network. Have you seen the Wi-Fi at home that we have Wi-Fi installed? So what happens that it is going to have a wireless connectivity with all the devices coming under that location, right? And that particular Wi-Fi access point has a wired connectivity further with the switches and further with the routers like that. So it is having one side connectivity as wired, one side as a wireless. That's why it device is called as an access point. So access point is a device that uses in the wireless communications that have the connectivity between the wired and the wireless network, right? And to access this multiple access point, we will be having one centralized device that is called as a controller, or we can sort in short we can call it as a controller only, or a wireless LAN controller is the example of this controller that is going to control multiple access points, right? Now endpoints, you know what are the endpoints? Like end devices, right? Mobile phones, laptops, computers. These are the end devices. Servers. So server is a physical device that is used for a storage purpose, for hosting purpose, hosting websites, for running apps, certain applications, for running certain virtual machines, all these things. So there can be multiple uses of these servers depending upon the types what we are going to use there. Even we can have DNS servers, NTP servers, network time protocol servers, right? Then power over Ethernet. So that means that we have certain Ethernet ports. That port can be used for power transmissions also and even for data transmission also. Same port you are using for power transmissions and same port you are using for data transmission. That's why we can call it as a power over Ethernet. Okay. Again, we'll discuss all these network devices. Next, we have it says to describe the characteristics of network topology architectures. It means we need to understand how the devices will be connected, how the devices will be placed in a network. So we have different types of architectures. So it has two-tier architecture. Then we have as a three-tier architecture, spine leaf architectures, then wide area network, then small office, home office, and on-premises cloud means cloud architectures, right? So this is the two-tier, three-tier architectures, but this is when you are having multiple devices, right? Large organization. Now we have certain topologies also. How you will be connecting multiple devices in a just local area network. There we can have bus topology, star topology, tree topology, mesh, hybrid, all these types of different topologies. And these are what architectures. How we are going to connect two-tier, three-tier. So two-tier means what? You will be having certain access layer switches and core layer switches, or we can say distribution layer. So some of the switches will be used to connect end devices. Rest again, we will be using certain different layers of the switches, right? So that's why see this two-tier architecture is preferred where in the small network. Three-tier architecture is preferred where large network, right? See why I'm talking all these things. All these things again we will discuss, but I don't want that when again we are discussing, it should be new for you because now you are getting what overview of the topics so that whenever second time when you listen about this all this topic, it should not be new to you, right? Then a spine leaf, it is preferred where in the data centers, this type of architectures. Then a small office, home office, SOHO architectures, where we will be having routers, switches, then access points, end devices. These are the example of the SOHO architectures. Then we'll discuss about the on-premise and the cloud. Then here it is written as a compare the physical interface and the cabling types. What are the different types of cables we have? Like we have here a single mode fiber, multi-mode fiber, copper, connections, point-to-point connectivities, different types of cables, like even we can have twisted pair cables, untwisted pair cables, fiber optic cables. Then we have console cables, crossover cables, straight through cables, right? All these cables where we will be using this depends upon the users. Next, it says you for identify the interfaces and the cable issues. Then compare TCP and UDP. See it's working or not. Check. Yes. So TCP and UDP, transmission control protocol and user datagram protocol differences we have to discuss because this is most important topic we can say, right? Always in the interview, a question will be asked, tell me the differences between TCP and UDP, right? Next. So like always you know that in layer 4 we have protocol TCP and UDP, but we will not discuss only TCP and UDP. I will tell you certain more layer 4 protocols, right? Then configure and verify IPv4 addressing and submitting. Because you know that we have IP addresses of two categories, IP version 4 and IP version 6. So now we are using IP version 4, and though we have IP version 6 also. So first we will be understanding about the uses of IP version 4, it classes, then what is the use of subnetting, what is subnetting, then what is block size, what is host part, network part, everything, right? Then it says disk drive IPv4 addressing. Then configure and verify IPv6 addressing and prefix length we have to identify it. And in this IPv6 address, uh, like submitting, we will be not doing, just we will be understanding the classes. We don't have classes, but we have here types. Like no classes is there, types we have. Then even under this, we have, see, it says that describe IPv6 address types, like we have unicast, in that global, unique local, link local, anycast, multicast, and extended unique identifier. EUI is what? This is called as a extended unique identifier, right? Then it says about the verifications of the IP parameters for the client operating systems. And then we have described wireless principles, like what is their known overlapping Wi-Fi channels, what is SSID, that is what is routing forwarding, then what is encryption, everything. Then explain virtualization fundamentals. Then we have describe switching concepts. So now it says switching concept means what? How the devices is learning the MAC address. If it is learning the MAC address, till how much time it will maintain that MAC address information. That is called as what? Aging time of the switches. Then frame switching, frame flooding, MAC address table, and everything. Right? So till here, what it is explaining you, all the components of the devices. Then after the components, we have to discuss about the IPv4 addresses, how you will be assigning the IPs, IPv6, everything. Next, you are telling, it is explaining you for network access. Means let's say once everything has been done, devices has been deployed, IP address has been assigned. Now what we want? Communications between them, network access. For that, you will be having certain different uses. That's why it is telling you what? Configure, verify VLANs. It means it is explaining you that now the devices are ready to communicate. Now in this particular network access, you will create topology, you will create the access, you will create the policies, how the devices should communicate, right? So that's why it is telling you that you will configure here what? VLAN, virtual local area network. Then it says that here we have certain called as a access ports. That access ports can be used for carrying what? Data and the voice traffic, right? Then we have certain called as a default VLAN. What is a default VLAN? VLAN number one is called as a default VLAN, right? We'll come to that part. Then what we have? Inter VLAN connectivity means to have the communication between the devices located in different VLAN is called as a inter VLAN connectivity, correct? Then it says configure and verify inter-switch connectivity, that is called as a trunk ports. So certain ports we have, that is access ports or the trunk ports. Then 802.1q, this is called as a tagging method. Like, okay, let's say you have to enable the communications between different LAN environment. So you want that this particular information should be delivered to only this particular uh, organization only. So what is required here? Tagging. Let's say when you send a letter, you write that address no on that. Yeah. That address is called as what? Tagging. Same here also, we will be writing the address. That if any information is getting originated from VLAN 10, you have to send it to VLAN 10 only. That's why based on this tagging, that particular information will be delivered to whom? To the VLAN number 10. And this is called as a tagging. And for this, we use one method that is called as a 802.1q method. Correct? Then we have a certain method called as a native VLAN. Next, configure and verify what layer 2 discovery protocol, that is called as a Cisco discovery protocol and link layer discovery protocol. So they both are used for verifying your neighboring information. What all the neighbors has been connected to the particular devices. So for that, we have two protocols. One is CDP and one is called as a LLDP. So to see this CDP is name only suggests that it is a Cisco proprietary. It means it's a Cisco feature. And LLDP is what? Open standard. It means IEEE standard. So it can be applicable with all other devices, but CDP will be applicable with only the Cisco devices. Then we have here configure and verify layer 2 and layer 3 Ether channel. So in Ether channel, what we do, we combines multiple different links to form a single link. Okay. In that, we have different methods. One is called as a LSCP and one is called as a PAGP methods. So LSCP is what? Link Aggregation Control Protocol, whereas PAGP is what? Port Aggregation Protocol, right? So here PAGP is a Cisco feature, LSCP is open standard. Then we have, it is telling you to interpret basic operations of the rapid PVST and the STP. So we have certain concept called as a spanning tree protocol. Similarly, we have rapid spanning tree protocol. So in that, we have to discuss about what is that root port, root bridge, primary, secondary, or other port names, like what is port states, port roles, port fast, then root guard, loop guard, BBQ filter, everything. So all this will be discussing in the spanning tree protocol. And these all topics comes under switching. Okay. Next, what we have, describe Cisco wireless architectures and access point modes, AV modes we have to discuss. Then describe and physical infrastructure connections of the WLAN, like what is access point, what is wireless LAN controller, what is this access and trunk ports, LAZ, everything. After this, it is telling you to discuss about the device management, means how to access that devices remotely, not directly, but remotely. For that, we can use here Telnet, SSH. Apart from that, we have certain other protocols like HTTP, HTTPS, console, TCAX plus, Radius, and the cloud managed. Then it is explaining you that we will be discussing here that interpret the wireless LAN using GUI. See, what happens, we have two different methods to access the devices. One is called as a CLI. What is CLI? Command line interface, right? So CLI, it means what? That here you will be using all the configurations for steps to configure the devices or to access the devices or to make certain changes. CLI, right? Commands we will be using here, right? But in the GUI, that is called as a graphical user interface. So what is the differences between them? CLI and GUI. Graphical user interface, it is like an application. In this, you will not use commands. You will use the steps. For example, you are using Facebook or Instagram. You want to upload your photo. All the steps you will follow, right? Go to settings, profile, upload the profile, everything. Same as in the GUI, all the things, all the changes you will be doing according to the websites, like clicking on the icons, making certain changes. Whereas in the CLI, what is required? Commands are required, right? So even though certain devices will be supporting this GUI, what the difference is that whenever you are going to have, let's say, troubleshooting, for troubleshooting purpose, what is being recommended? CLI is recommended, right? That's why here it's explaining you that you have to interpret the wireless LAN using what? GUI configurations. Means here we will be using a wireless LAN controller to configure certain wireless concepts. And what we will be using? GUI, not CLI. But when you will access the routers and when you will do the configurations on the switches, always you will prefer CLI, right? It means we have to remember the commands, correct? So next, okay, so it is telling you, right, what is your quality of services, profiles, advanced settings, and all these things. So this is regarding the network access. Next we have is called as the IP connectivity. So connectivity means what? IP means what? That as whenever IP is coming, it means one thing should come to your mind, that is layer 3, because IP is belonging to a layer 3, right? So here we have certain routing protocols. Then here we have certain prefixes, network mask. Next hop means next device, next router. AD value, we have certain concept called as the AD value, administrative distance values. Now metric, gateway of the last resort. We'll discuss everything. What is this gateway? What is this administrative distance? What is next hop? Everything, right? Then what it says, determine how a router makes a forwarding decision by default. Like whenever router forward the traffic from one location to another location, on what basis it is going to find the best path, based on the routing, based on the longest prefix matches, based on the AD values, and based on the routing protocol metric. So there are different particulars methods for forwarding means data from a source to a destination, and that is called as what? Forwarding decision by default, right? Then again, it says that you have to use here static routing. So we have to discuss the static routing using both version 4 also, version 6 also. And even we have certain called as the default route, network route, host route, and the floating static routing. See, for the routing, we have different methods. In the routing, we have method called as a static routing. Static means what? Here, everything will be manually configured. Means you have to decide what router will take, which path will router take to forward the data from one place to another place. But that is fine that, okay, we will be deciding that which path that router has to take to forward the traffic. But don't you think that when you have very large network, so for you to decide which path router should take will be always very much time consuming, very much like a lengthy process. So what we prefer? We prefer dynamic routing. That is going to be automatic. In dynamic routing, what happens that we will be having certain other protocols. Based on that protocols only, the routers will find the best path automatically, right? So at CCNA level, we have to discuss certain dynamic routing protocols like OSPF. Only OSPF is there, but we may also discuss about the RIP and EIGRP in short, in like introduction part, because in detail it is there in the CCNA, right? Next, we have IP services. In that, it is telling you to configure and verify what NAT, network address translation. In this, we have different types of methods, static NAT, dynamic NAT, and the NAT overload. Then it is telling you configure and verify what? NTP operating means network time protocols, and explain the role of DHCP and DNS where within the network. Role of DHCP and the DNS. Explain the functions of the SNMP. Function of what? SNMP, network operations. Describe the use of syslog features, including facilities and the safety labels. Then configure and verify DHCP client and relay. Then it says your quality of services. In this, we have marking, queuing, congestion, policing, and shaping. All these things we'll discuss. Configure devices, network devices for remote access using SSH. We'll also do the telnet, not only SSH. Then functions of the TFTP and the FTP. That is file transfer protocol and the trivial file transfer protocol. And at last, we have security fundamentals. This is second last is your automation. So security fundamentals. So where it depends upon the key security concept, like what is threats, vulnerabilities, exploits, and mitigation techniques. Describes user awareness, training, and physical access control. Then configure and verify access control using what? Local passwords, like we'll be doing here, enable password, login passwords, enable secret passwords, all these different methods to secure our devices. Then what it says that describes security password policy elements such as management complexity, password, and here we have multi-factor authentication, certificates, biometrics. Then describe the IPsec remote access, site-to-site VPNs. Even we have to discuss VPN in this CCNA level. Configure and verify what? Access control list, ACL. ACL is again one of the most important topic. Then configure here what? Certain mode security topics are like DHCP snooping, dynamic ARP inspections, and port security. Then we have one concept called as a AAA, authentication, authorizations, and accounting concepts. Wireless security protocols like WPA2, WPA, WPA3. That is called as a Wi-Fi protected access. Even we have one WEP. That was the first one. Okay, so we'll discuss that one also. Then configure and verify wireless LAN using what? GUI and using what? PSK means what? Preset key. So we will do the configurations of the wireless also. Finally, we have automation and programmability. So in this, we have to discuss, this is explaining you that here we have certain theory topics only, where we have to understand what is a traditional network and will be comparing it with the controller-based network, right? Differences between them. Then what is that called as a overlay, underlay, and fabric? What is separation of control plane and data plane? Then northbound API and the southbound APIs. And here you have one new topic that is called as a AI. Explain AI. In that we have to discuss generative AI, predictive AI, machine learning, and the network operations. Even we'll discuss what is deep learning. Okay. Then describe the characteristics of the REST-based APIs and like what is CRUD, HTTP verbs, everything. And here we have Terraform and Ansible, and at last we have JSON data, how it looks like JSON format, right? These are the languages. So these are the topics that we have to cover under this CCNA. Till here, any questions, any doubt you have regarding the syllabus? No? So we will be covering all these topics, but not in this way. Our sequence will be changed. So we'll write now our sequence, what we are going to cover, okay? So now from here, you're going to start writing, right? So we have CCNA, that is called as what? Cisco Certified Network SOC, right? So first topic that we will start is network devices. What will start? Network devices. In that, we will discuss about what? Routers. First, we will discuss hub, switch, router, first server, then firewall, then access point, right? Then let's say we may discuss about the modem also, modems, correct? Then we will discuss about the network topology. In that, what we have? Bus topology, ring topology, star, tree, mesh, hybrid, and hybrid, right? Then OSI model.
One is forgotten. 1 to 1.5.
Point one that will be there. One-to-one connectivity it is only, right? So OSI model we will be doing. So in that we don't have it. It is not there in that syllabus of the Cisco syllabus, but we have to discuss all this OSI models layers, all the 7 layers in detail. Then what we'll discuss? TCP, IP model, right? Then transport layer protocol. Which layer protocol? Transport layer protocol. First transport layer protocol we'll discuss. Like examples can be like TCP, UDP, SSL, TLS, right? where we'll discuss TCP and UDP. That is called as what? Transmission Control Protocol and the User Datagram Protocol. Then we have application layer protocol. So in the application layer protocol, we have certain like telnet, SSH, then HTTP, HTTPS, FTP, TFTP. What is HTTP? Hypertext Transfer Protocol. SSH, Secure Cell. Telnet is what? Teletype Network. FTP, File Transfer Protocol. TFTP, Trivial File Transfer Protocol. Then DHCP, Dynamic Host Configuration Protocol. DNS, Domain Name Server. Then NTP, Network Time Protocol. Then IMAP, right? Then SMTP, Simple Mail Transfer Protocol. Then POP3, then SNMP, then syslog. All these application layer protocols we'll discuss. Clear till here? Then after this, we'll start with the cables. Where we will be discussing about twisted pair cables, crossover cables, and all these cables. Then after discussing this cable, and we will do here only after this transport layer protocol. Okay, well after this only, let's say here only we will do IPv4 addressing. After understanding this network topology, we will start with the IPv4 addressing. And also we'll discuss what is that? MAC address. Here only. After cables, we'll start with the one protocol that is called as an address resolution protocol. Then ICMP, Internet Control Message Protocol. In this ICMP, we'll discuss what is that ping and trace route. In the ARP only, you have to add some more. What is proxy ARP and what is DR? These are not written in the syllabus, right? Yeah. Next, default gateway. We have to discuss about what default gateway. Then we'll start with what? Routing. In this, we will discuss static routing, default routing, and dynamic routing. In the dynamic routing, what we will discuss? Routing information protocol, EIGRP basics, and OSPF. Open short is path first. BGP is not there in the CCNA. Then, first we will discuss ACL. access control list, and then we'll discuss NAT, the network address translations, ACL and NAT. After this, IP version 6. In the IPv6 also same concept, static routing, default routing. After IPv6, we'll start with the switching topics, like what is VLAN, virtual local area network. Next, what is inter VLAN? Then DTP, that is dynamic trunking protocol. Next is what? VTP, that is VLAN trunking protocol. Next is what? STP, that is spanning tree protocol. Next, RSTP, that is rapid spanning tree protocol. Then Ether channel, correct? After this, DHCP already we have written, but we have to do the DHCP configuration as well. So DHCP configuration and then DHCP delay. Then DHCP spoofing. Then snooping. Spoofing and snooping. ARP inspection. Then what? Port security. Wireless configurations. Certain security fundamentals. Then cloud basics. AI basics. Then automation, network, architecture. So this is a sequence that we are going to follow. And after that, whatever the topic left will be covered at last. All the practical will be done where? Practical will be done on Cisco Packet Tracer. Clear? Till here, any questions, any doubt? No questions? Huh.
But before, because was from this or this.
Syllabus are same. The difference is that sequence is different. That syllabus is Cisco syllabus or Cisco CCNA syllabus, right? And here, this is the same syllabus only, just this is our sequence, how we will be covering the topics, right? Everything is same only. And even we have added certain more topics under this to understand the basic fundamentals, right? So here we have two books. One is version 1, volume 1, volume 2, CCNA 200301. So we'll be also referring to these two books. Okay. And rest we have certain PPTs. So CCNA, Cisco Certified Network Associate, it is telling you that this is an entry-level information technology certification issued by network company, that is Cisco. So who was the founder of the Cisco? It is Leonard Bosack and Shandy Lerner. Headquarters is where? San Jose, California, US. Okay. This is the certification path. It says that here we have certain called as a Cisco's first is CCNA. Then we have his professional level, that is called as a CCNP, where we have CCNP Enterprise. So it is telling you enterprise, we have collaboration, service provider, security, and data centers. Most preferred is enterprise and security. Then only anyone can prefer this data centers, right? Next is what? CCIE, Cisco Certified Internet Network Expert. Here also we have different like enterprise, security, wireless, data centers like this. So here also same thing, enterprise or security is most preferred, right? Next, before starting, first you tell me what do you mean by this term network? Tell me first what is a network?
Sir, a network is a digital telecommunication between two nodes uh, who share their files and resources.
Hmm. Yes. What do you mean when the term network? Ah, you are correct. I want to know from others as well, no?
The path between like two devices, like to communicate.
Hmm.
Yes, sir.
So network is what? It is a connection. It is a connection between two devices, two, not only two or
One more nodes.
more devices to exchange data, files,
Resources.
resources, and other informations. Right? So it is a connection between two or more devices, or we can say between the two or more nodes to exchange data, files, and resources. So as it is, the term only is telling you that here we have connectivity with what? With the devices. So first we need to understand what are the devices we can use in the network to have the connectivity or to have the information exchange between them, right? So let's say first devices that we have taken here is called as a hub, right? So now what happens, for example, if you have taken a hub device and then you have taken here two PCs. This is what? This is PC1. This is PC2. And what this is? This is a hub. So this PC1 and PC2 has been connected to the hub. Now what we will do, we will take one more device, one more PC. Same, this is also connected with the hub. This is PC3. Now what happened? Let's say PC1 want to send the traffic or to send any data to the PC2. What will hub this do? What does this hub will do? Will receive the information from PC1, will send this information to the PC2, only PC2?
No,
No.
it is going to be like
It
broadcast
will, yeah,
whatever
it will
thing.
receive the information from PC1 But instead of sending this information to only PC2, it will send it to the PC3 also. What is the reason and what it is doing? So we can write here that hub will broadcast the information. Now you tell me, what do you mean by the term broadcast? Broadcast means what? Sending the information to all the nodes. Broadcast means what? To send it to everyone. So what it does, whenever it is receiving an information from any particular device, so rather than sending it to only one single devices, what it does, it broadcasts that information. Hub will broadcast information. Now question arises, why does this hub broadcast this information? The reason, hub cannot learn the MAC address and IP address. That's why whatever the information it is getting, it is sending it to the all other nodes. Because see, let's say you told that, okay, I want to send it to, let's say A is sending something. He is sending to the B. So what this hub will tell that, okay, I don't know where is that B. So whatever I am receiving, I will send it to all. Whoever is that B will receive and rest other will drop, right? That's what it's doing. But don't you think that if always, let's say now PC1 is sending, so hub received that information from PC1, he delivered it to PC2 also and PC3 also because he was not knowing where is my PC2. Later on, let's say if PC3 is sending, again what hub will do? Will receive from PC3, will send it to PC1 and PC2. Don't you think that always my traffic will be more high traffic? So we can say here that more traffic. More traffic will be there with this particular hub device. Now, you tell, whenever we have more traffic, don't you think that there will be more chances of collision? Huh? Yes, it means we can write what? More collision, more traffic, more collision in a network. Then what you can write? Means data collisions can take place, data loss can take place, right? Always same thing is being repeated. So hub, we can say this is physical layer device. Why we call it as a physical layer device? The reason, because it operates on layer 1 of the OSI model. It is not having any software components. If anyone is having software components, what it will do? It will receive something, it will forward something. But as it was not having any software concepts, software components, that's why we call it as a purely hardware device or purely physical device, physical layer devices. Correct? Then it has single broadcast domain. It means what? Single broadcast domain means what? If any device is sending, all other device located in that network will receive that information. That's why we call it as a single broadcast domain. Then it has single collision domain. See, when we will discuss about the switch, in the switch we will call per port collision domain. What we will call per port collision domain. But here we don't have per port collision domain. It means here we have single collision domain. It means that if PC1 is sending, then let's say PC1 is also ready to send something and PC3 is also ready to send something. So if at same time they both will send, what will happen? Collision will take place because this is operating on what? Broadcast domain. So what this PC1 and PC3 will do, if PC1 is sending, PC3 will wait for certain seconds, then it will send. To avoid what? To avoid the collision. So we can say that hub operates on half duplex modes of communication. It supports half duplex modes of communication. What do you mean by this half duplex? One is sending and other device is also receiving. Same time, other device will also send, but not at the same time. It will wait for certain times to send. That's why we call it as a half duplex modes of communications. So what can be the examples for this? One is walkie-talkie in real scenario, and one is hub that operates on the half duplex modes of communications. Clear? Now you will ask, what is this? See, we'll discuss that. It's sure that we'll discuss the MAC address again. But as a term has come here, so what do you mean by this MAC address?
MAC address is a physical address, and
Yes.
and hardware. MAC address is also known as a permanent home address of the devices.
So in short, we can call it as a physical address. And what is this? IP address. In short, we can call it as a logical address.
Can change.
Correct? Now, see, you know that where will we use this physical addresses? To have the communication in the local area network. Why? See, for example, let's say two employees are there, A and B. They both are working in a same company. When anyone is telling to you that CA, you have to give this file to B. As you know that this B is working in my same company. So what is required? Only physical name. So what you told, what you asked, whom I have to give. So he's telling you have to give it to B. So physical address is required, right? Now let's say that particular B is not working in your company. So what you will ask, where is that B? Where he is working? So what you ask now, apart from name, you are asking his location, his logical address. So when the devices are not there in the same network, what is required? Logical addresses that we call it as the IP addresses. Whereas when devices are located in same network, then this MAC address is enough to have the communications, right? That's why in general, whenever we are having the communication in the LAN environment, we use MAC addresses. And whenever we have to use the communication between the different LAN environment, what we use? Logical addresses. But this hub cannot understand MAC, cannot understand IP. That's why it is coming under layer 1, because MAC will come to layer 2, IP will come to layer 3, and it cannot understand both. That's why it is coming under layer 1, right? Then one more point you can write for the hub. It is a layer 1 device that is used to connect multiple device in local area network. It has less number of ports. It means if it has less number of port, it means what? Less number of devices can be connected using this. Uh, how many, like 4 ports, 8 ports, 12 ports? What if we have more than that devices? How you will be using that, right? That's why these are the limitations of the hub. And whenever you are explaining the hub, then you have to tell that this hub is a very old device, not preferred now, right? So what happened that, as you know, that this hub was having less number of ports. So let's say you have taken 20 devices and you have one hub that is going to allow only how many connectivity? 8. So again, you will take one more, 8 plus 8, 16, let's for example. So to connect between them, to have a connectivity between two hub, again, you require one more device that is called as a bridge, right? So bridge is a layer 2 devices that have the connectivity between two LAN segments. I'm not telling that bridge will be connecting two different LAN. No, same LAN but LAN segments. But advantage is that bridge can understand the MAC address, right? So you can write here, bridge is a layer 2 device bridge is a layer 2 device that enables the connectivity between LAN segments. It can learn the MAC address. It means bridge can learn the MAC address. So what we can do here, that let's say you have taken one hub here, this side. All this spent file you will get. Whatever I am writing, everything you will get. Right? So now we want to have a connectivity between them. So what is going to be used? One more device. That is called as what? Bridge. So this is one LAN segments. They both are same LAN only, but has been further divided into small LAN segments. And that's why here we have used one bridge device. Right? So we can say here that these bridges are replaced with what? With the switches. Even some of the companies can prefer these bridges, but now we have more advanced devices that is called a switch. Correct? So like when we will talk about the switch, it has more features compared to what we had in the earlier devices, right? See, as of now, first we will focus and we will understand here that this switch is a layer 2 device only. Okay, because generally it acts as a layer 2 only, but we may have layer 3 switches also that can have the capability of acting as a what? A router. So as of now, what we will understand, we will focus that it is a layer 2 device, right? So it is a layer 2 device that enables the communication between the devices located in local area network. Or in short, we can say it enables the communication within local area network. Within is important here because when you will write layer 3, that is not within, that is between, right? It is within the local area network. Now understand here what will happen when you will be using here switches, right? See, for example, we have taken switch. This is what? PC1. This is PC2. This is PC3. This is PC4. And this is PC5. See what happens here. If let's say PC1 want to send traffic to the PC2, what happens? What do we want? PC1 is sending any traffic to the PC2. What will happen? This PC1 will send it to the switch. What does the switch will do? It has to send it to the PC2, but what it will do? It will send it to the PC3 also, PC4 also, and PC5. What it is doing? It is receiving the information from the PC1, but rather than sending it only to the PC2, what it does? It send it to 3 also, 4 also, and 5 also. Then you will ask me, what is the differences between her and this one? You told that this is advanced device, but don't you think that this is again doing the broadcasting? Okay, but here the situation comes. Here, what happens that for the first time, this switch was not knowing who is PC2, where is PC2, with what port numbers PC2 is located. That's why it broadcasts the information. Once it has received and once it has replied, it will maintain both the information. And next time when they will communicate, they will have a unicast communication. It means one to one. So what you can write here, what we will write for the first time when end device sends traffic to the switch, it broadcast, right? Why? Because of our request. I'm not discussing ARP here. We'll discuss ARP later on, but I am writing the reason. What is happening? This is because of ARP request. When end device sends traffic to the switch, it broadcasts because of ARP request. Now see what happens. PC1 and PC2 want to communicate. Don't you think that they both require what MAC address information?
Yeah.
Because that is in the LAN environment. PC1 is not knowing the MAC address of the PC2. What PC1 is sending, see, PC1 will say that I want to communicate with the PC2, but I don't know the MAC address of the PC2. Tell me the MAC address of the PC2. Who is telling you? PC1 is telling. To whom is telling? Switch. Switch will tell even I don't know. You are asking me, tell me the MAC address of PC2. I don't know. Who is PC2? Let me ask who is PC2. Let me ask your MAC address, his MAC address. So when he is going to ask that PC2 tell me your MAC address, he will send it to 2 also, 3 also, 4 also, and 5 also. Tell me the MAC address. So what PC2 will tell? This is me. This is my MAC address. We'll receive the switch. We'll forward it to the PC1. So PC1, what it sent? ARP request. PC1, what it got? ARP reply. In what form? Unicast. They both have communicated. When, let's say, this is port number F01. Which port? Fast Ethernet F01 port. This is what? F02, fast Ethernet 2 port. So when they both have communicated, so switch will maintain, okay, this is F01, with this F01, PC1 is there. And if this PC1 is there, so PC1 is having a MAC address AAA. That's why I will maintain this information as a AAA. PC2 has given a reply. It means what? This is my PC2. It is telling this is my MAC address, let's say triple B. So I will maintain F02 as a triple B. So what this switch is going to do? It is going to maintain what? MAC address table, right? For example, what I'm telling you, Here I'm telling you that let's consider that MAC address of the PC1 is what? AAA. This is the MAC address of the PC1. What about the PC2 MAC address? I'm telling you that let's consider that MAC address of PC2 is triple B. So when this switch will maintain this MAC address table, how it is going to maintain that? It will write that if 01 is having a MAC address AAA, right? Now, how it is learning this? Automatically, right? So what it will write? Dynamic, correct? Then what it will tell? This is F02. F0, what is this? Triple B. Why I'm learning? Automatically. Dynamic. So this is called as a what? MAC address table. Port numbers, MAC address, how it is learning. So this is the MAC address of what? Devices. That particular devices that is being connected there, right? Because it is sending the traffic, correct? So each interfaces will be having each devices. When they communicate with themselves, what it does, it maintains a MAC address table, right? See, when they have maintained the MAC address table, it is not permanent. Because for example, let's say today you have connected this PC. Tomorrow or after the certain time, what you did, you removed all these PCs. You want to connect new PCs. How many times your switch will maintain all this MAC address information? If it start learning all these things permanently, what will happen? It has certain memory capacity, no? It has to delete certain information. That's why whenever it is learning the MAC address, it is going to maintain that MAC address table for 300 seconds. That is called as a 5 minutes. If till 5 minutes they have communicated, that is fine. If they have not communicated, again, they will require what? Broadcast, right? So we'll again discuss that part. So as of now, you can write here that switches for the first time, it support what? Broadcast. Then it support what? Unicast. And what could be the reason for this broadcasting? ARP request, address resolution protocol. And later on, we'll come to this ARP request, ARP topic. Clear? One more thing. See, don't you think here we have more numbers of devices? It means in the switch we have, it has more numbers of ports. It has more number of ports. It has more number of ports. More devices can be connected with the switches. It has single broadcast domain. Only one broadcast domain we have with the switches, that is called a single. That's why if for the first time, if it is communicating, so every other devices is going to receive that information. That's why we call it as a single broadcast domain. But here, one different thing is there that it has per port collision domain. See, when we say that it is having a per port collision domain, this is an advantage, not a disadvantage. Per port collision domains means what? This means every port is independent. It means what? Every port is independent means what? If PC1 is sending, PC3 will not wait. If PC3 want to send, he will send. Right? He is no other port is going to wait. But in the case of hub, it was happening no. If PC1 is sending, PC2, let's say, port number 2 has to wait until and unless PC1 has delivered for certain seconds. Why? To avoid the collision. But in this, it is not required. There is no any requirement. Why? Because every port is acting as an individually, right? Though it is having a broadcast feature for the first time, that too also each port is acting as an individually, that we call as a, it has per port collision domain. And that's why you have to write here that it operates on full duplex modes of communication. What you will write? Switch operates on full duplex modes of communication. These are the features of the switches, right? Any questions, any doubt?
Which has single broadcast domain, but first time, the next time it will do unicast. Then why we call it single broadcast domain?
Because first time it is doing the broadcasting, no?
After they will not end it.
That is fine. But once that MAC address table has been removed, do you think again they will require the same thing? Huh? Okay, that is fine. That second time it will do the unicasting. But don't you think that first time it is doing the broadcasting? So first time it is doing the broadcasting, but unicasting is dependent upon certain conditions. If that condition is not existing, what if it will do again broadcasting will be done? No. That's why we call it as it has single broadcast domain. And that single broadcast domain is called as what? Do you know? VLAN 1. Okay. And this is the default VLAN. What is VLAN? Again, we'll discuss when we'll start the VLAN. Why I'm telling you now, because when you will revise this all the topics again, let's say you have completed CCNA. When you are revising the concept, you can correlate all these things. Okay, we discussed in the first class that it was coming VLAN number 1. And when we are discussing VLAN, there also you can correlate, okay, this is my VLAN number 1. That's why we have a single broadcast domain and it is called as what? VLAN number 1. It can be changed and there is certain ranges also that we will discuss when we start the VLAN. Clear?
Hi Vishal.
Hmm.
How long this MAC address information will switch is going to hold?
300 seconds.
300 seconds.
5 minutes. That is aging timing of the MAC addresses. But
Okay.
when you talk about the, let's say this PC1 received and PC2 also received MAC address information, they will hold it to till 120 seconds. Right? It depends upon the operating system as well. I am talking about the Windows. If you have Windows devices, so it is going to maintain that till what? Till 120 seconds. Right? So here we have discussed that this is the switches that operates on the full duplex modes of communications. Now what we have, even we have two categories of the switches. What is that? One is called as a managed switch, and one is called as a unmanaged switch. Now you tell me what is the differences between the managed and the unmanaged switch? Tell me. See, unmanaged switch means what? Whenever you have taken a switch, just you have connected the devices, connectivity is established, and no any policy you have created. There is no VLAN, there is no rules, there is no any port security, then it is called as an unmanaged switch, right? So we can write in managed switch, management of the devices is allowed based on VLAN, or you can say port security, or you can say telnet, or SSH, or etc. This is the example of the managed switch. Unmanaged switch, just plug and play. In unmanaged switch, plug and play concept is there. It means there is no any other feature like you will be doing management here. Okay. So what we use now, managed switch. We can have VLANs. We can have port security over there. We can have port security over here. We can do telnet. We can do SSH. That's why that is example of what? Managed switch. Till it is clear? So we have discussed about the hub, just brief small introduction about the bridges, and that introduction and discussion about the switches. Any questions, any doubt? You want me to start router? Hmm?
Did you create?
My question is, you want me to start router per port collision domain? Okay. See, for example, consider here that what happens. This is switch. With this switch, we have F01 port, F02, F03, F04, and F05. 5 ports. So per port collision domains, meaning is that each port is independent of each other. It is not going to affect other ports, right? So F01, if any traffic is coming from F01, F02 don't have to wait. It will send. Same as F03, it does not have to wait. Whereas in the case of hub, it has to wait. Why? Because that was having single collision domain. Here we have per port collision domain. It means each port is acting as a independently. Why it is happening here? Because switch sends traffic based on what? Full duplex modes of communication. Where I have written that. Hmm. It operates on the full duplex modes of communications. Means sending and receiving the traffic at the same time without any delay. That's why we call it as a per port collision domain, right? And see, what is this domain only? See, this is one of the example of the hub where it is telling you that hub is a physical layer networking devices which is used to connect multiple devices in a network, and they are generally used to connect multiple computers in a LAN environment, right? Next, what we have switch. These are the example of the switches where we have more numbers of ports. So a network switches is a technology that allows you to connect more devices, and not only end devices like PCs, we can also connect printers, servers, and etc. as devices. It has more numbers of ports, right? We can create policies over this switches. So we'll come to this part later on, later router. And here you have certain called as a domain. See, we are telling always broadcast domain and collision domain. So before that, we have domain. So what is that domain? Domain is what? It is a network. It is a network domain where it is an administrative grouping of multiple devices, networks, or local host within the same infrastructure, right? So what you will write, domain is what? Domain is administrative grouping of devices within the same infrastructure. Domain is administrative grouping of devices within the same infrastructure, right? Here we have two types. One is what? Broadcast domain. So what is written here? What is broadcast domain? Network or part of network where a node can use a broadcast message to deliver the message to each and every other node in the network. That is called as a broadcast domain, right? So what you will write? If each and every node of the domain receives any information, then we call it as broadcast domain. Next is what? Collision domain. What is that collision domain here? Network are part of network where there is a possibility of the collision, right? That is called as a collision domain. So what you can write? Network or part of network where there is possibility of the collision. Okay. So example what we gave, switches has per port collision domain and how has single collision domain. So tomorrow when we'll start the class, we'll start here from here only. I will give you one scenario and you have to identify in that scenario how many broadcast domain we have and how many collision domain we have. Then further we'll start with the router, then modems, servers, firewalls, access points, topologies, and if time permits, we'll start with the IPv4 addressing. Right? So for today, that's all. We'll stop the recording.